in Mars. Do you want to come with us?
Yes!
Great! Let's go!
But wait, how can we go to the Mars?
That's easy. Let's draw
The map!
If there's a place you gotta go, I'm the one you need to know. I'm the map. Place you gotta get, I can get you there, I bet. I'm the map.
First, let's go to the volcano island.
Thank you, Map. Now, are you ready to go on an adventure with us? Vamonos to the volcano island! What's that noise? Do you hear that noise? Come on, let's check it out!
Help! Please, help me!
Are you okay, mister?
No, the chicken egg that I was about to sell accidentally fell down into the water!
Oh no! Should we help this man? Okay. Oh, that's easy. Let's go. Backpack, backpack. Say it with me now. Backpack, backpack.
Good day, scientists! Here's a floating egg experiment materials. 2 raw eggs, 2 transparent glasses, water, salt, and a steering rod. And here's the procedure. Step 1. Fill 1 glass with plain water. Step 2. Fill the second glass with water and stir in about 5 tablespoons of salt until dissolved. Step 3. Carefully place 1 egg into the glass with plain water and observe. And step 4. Place the second egg into the salt water glass and observe. And here's the result and explanation. In plain water, the egg sinks because its density is greater than that one with water. In salt water, the egg floats because the dissolved salt increases the water's density, making it greater than that of the egg. That's it, scientists. Bye-bye.
Let's make a straw move using static electricity. First, take a plastic straw and rub it with a wall cloth for about 10 seconds. Now, place the straw on a smooth surface and bring your hand close to it without touching the straw. See that? The straw is attracted to my hand because of static electricity. Try it yourself and see the magic of science.
Hello everyone, today we're doing the smoky fingers experiment. For this, we need a matchbox, a lighter, and a fireproof surface. First, cut off the red phosphorus part on the side of the matchbox. Then light it on fire and wait until it cools down. Once cooled, take the burnt remains and put them on your fingertips. Finally, rub your fingertips together and you'll see a thin smoky effect. And that's all. Thank you.
The sticky ice experiment demonstrates a phenomenon of regulation where pressure lowers the melting point of ice. But first, you'll need a few things: an ice cube, a bowl of water, and a piece of string. Next is to place the ice cube in a bowl of water. Now lay the string across the middle of the ice cube so that part of the string is touching the ice and the ends are hanging. Then, sprinkle a little bit of salt directly onto the part of the string that's touching the ice. Now wait for a few moments. Try not to touch or move the string during this time. Finally, gently pick up the string. If you've done it right, the ice cube will lift up with the string. Sticky ice experiment demonstrates the phenomenon of regulation, where pressure lowers the melting point of ice. When an ice cube has a string placed across it and salt is sprinkled on top, the salt dissolves in a thin layer of water that melts due to the pressure of the string and lowered freezing point caused by the salt. As the salt-laden water refreezes, it incorporates the string into the ice, effectively gluing the string to the cube, lifting the string, then lifts the ice cube, showcasing how melting and refreezing, influenced by pressure and impurities, can cause ice to adhere to an object.
Pour a milk into the plate. Add 2 or more color ink into the plate of milk. A1 pieces of Q-tips that put a little amount of liquid detergent. Now tap the milk with the Q-tips. Play, sister.
It's hot in here.
Oh look, who's that?
Who's that?
Welcome to the volcanic eruption competition.
Hi everybody, are you curious in how to make an elephant toothpaste? First, let's gather the materials. A small beaker, 1 Erlenmeyer flask, hydrogen peroxide, liquid dish soap, food coloring is just an optional, dry yeast, warm water, a tray to catch the foam, and lastly, the safety gloves for protection. So here are the steps in making elephant toothpaste. First, in a small beaker, mix dry yeast with warm water and let it sit for a minute. Second, place the Erlenmeyer flask on a tray. Third, pour a cup of hydrogen peroxide into the Erlenmeyer flask. Fourth, add a few drops of food coloring and a dish soap. Shake the bottle gently. Fifth, or step 5, pour the yeast mixture into the Erlenmeyer flask. And lastly, watch as thick foam erupts from the bottle like elephant toothpaste. So here are the explanation of that experiment. The yeast acts as a catalyst that speeds up the breakdown of hydrogen peroxide into water and oxygen gas. The soap traps the oxygen gas, creating a large amount of foam that rapidly expands. The reaction is exothermic, meaning it releases heat, which you can feel if you touch the Erlenmeyer flask. These experiments are simply yet a visually impressive way to explore density and chemical reaction.
Hi! Today we'll be making a volcano eruption project. The materials we'll be needing are the following: the baking soda, vinegar, dishwashing liquid, and the food coloring. So first, we'll be putting the baking soda. Next, the food coloring. Third, the dishwashing liquid. Let's mix the 3 materials, and finally, we'll add the vinegar. And ta-da! You have your volcano eruption project.
My name is TJ Misa and I'm here to observe the rapid release of carbon dioxide gas when metals are dropped into coke, causing an explosive soda volcano. The materials is 1 bottle of coke, 3 Mentos candies, an outdoor space to avoid mess. The steps is place the coke bottle on a flat surface outside. 2. Open the bottle carefully to avoid shaking it. 3rd is drop all the metals at once and step back immediately. And 4th, observe as the soda erupts like a volcano. That's all, thank you.
And now we'll be creating a carbon sugar experiment. First, we put a lighter fluid on top of the soil. Then, put on top the lighter fluid with soil, the mixed baking soda and sugar, and then light it with a torch. And watch as the mixture of baking soda and sugar rises.
So, what do you think?
It's hard to choose because all of them are great. How about you guys? Who do you think should win? I like that too. Oh, look at the time. I have to go to Caveman Kingdom. See you later.
I'm the map, I'm the map, I'm the map, I'm the map, I'm the map!
What's that sound?
Did you ever hear that sound?
Let's go check it out!
Hello, Mr. Caveman. What?
He says he wants to see great things in life.
Oh, I know. Let's use our educational tablet to show him what he wants.
First, you need baking soda in a clear container, vinegar with food coloring, and oil. First, you pour oil inside the container. And then flashlight. And then vinegar with food coloring. And now you have a homemade lava lamp.
Hi everyone, today we'll be doing a fun experiment called the dancing raisin. For this experiment, we need a carbonated drink like Sprite, some raisins, and a beaker. Now let's start. Fill the beaker with the carbonated drink. Drop a few raisins into the glass and watch as the raisins start to move up and down like they're dancing.
For today's experiment, we'll be doing the invisible ink experiment. First, you will be needing baking soda. Put it in a container and mix it well with water. Next is you will be needing turmeric. Put it in another container and mix it well with alcohol. After making sure that your mixtures are done, get a cotton swab and dip it in the baking soda mixture. Write it on a paper and let it dry for a few minutes. Next is to get a paintbrush and dip it on the turmeric mixture. Apply it to where you drew on earlier and watch the magic happens.
Hello everyone! Today we're going to try the exploding lunch bag experiment. The materials you will need are 1 small Ziploc bag, baking soda, vinegar, and a measuring cup. Add 1/2 cup of vinegar into the Ziploc bag. Put 1 tablespoon of baking soda into the bag. And then, quickly zip the bag completely closed. Step down or step back, then the bag will start to expand and boom! It will explode if it all goes well.
The experiment is called fireworks in a jar. The materials needed are oil, water, and food coloring. First step is to pour oil in a container and put some droplets of food coloring in it. Next step is to gently stir the mixture. And lastly, pour the mixture inside a water and see the magic happen as the food coloring stains the water.
So now we're gonna have experiments called gummy bear osmosis. So the instructions here, we have the materials. We have gummy bears, 4 small beakers or jars. We have vinegar, salt, sugar, and clear water. First step, we need to label each cup. We have vinegar, salt water, sugar water, and clear water. So that it will make a salt water and sugar water, we need to dissolve the salt and sugar in the water. So fill each beaker of water and dissolve first the sugar and the first beaker with the water, and the second beaker dissolve the salt. Next is place 1 gummy bears in each beaker and leave it on a minute. After any minutes, we will observe the gummy bear. So it happens that the clear water, the gummy bear absorbs water through osmosis, making it larger. The sugar water, it became smaller because the sugar concentration in the water is higher than the sugar inside the gummy bear. Through osmosis, the water moves out of the gummy bear into the sugar water to balance the concentration, causing it to shrink. So the next is the salt water. The bear shrinks because water leaves the gummy bear to balance the salt concentration. Next is the vinegar. The gummy bear expands in the acids. Vinegar may also slightly break down the bear's gelatin. It also, the salts turns smaller. This happens because of the osmosis. Water inside the gummy bears moves out into salt water, which has higher salt concentration. As a result, the gummy bear shrinks. So it will become a large, and
smaller, and a medium. Or also, just the same.
The balloon science experiment. This simple experiment contains only the following material: 1 straw, 1 empty bottle, 1 balloon, and a cup of water. So balloon fountain experiment demonstrates air pressure by using a balloon to force water out of a bottle through a straw, creating a fountain effect. When the bottle is inflated, the air pressure inside the balloon increases. The balloon deflates, the air pressure inside the bottle increases, pushing down on the water in the bottle. The increased pressure forces the water out of the straw, creating a fountain effect. And there you have it, a balloon fountain.
Amazing, right? Oh, look at the time. I'm sorry, Mr. Caveman, but we have to catch a party. See you later. Wow, it's so spacious inside the rocket ship.
What? Who's that?
Is it Dad? Is it Uncle? It's Diego!
Wow! Hello, Dora! You're invited too? Hello, Dora!
Who's that little kid?
I don't know his name, but he's crying because he can't watch his favorite TV show.
Oh no! We should help him. Do you want to help him? Yes! Okay, let's gather all the materials we need.
Skittles experiment. In this experiment, you will be needing the following materials: a pack of Skittles or similar candy with a colored coating, a white plate or shallow dish, and warm water. To conduct the Skittles experiment, arrange Skittles in a circle on a plate. Pour warm water into the center and watch the colors dissolve and spread, creating a rainbow effect. The colored sugar that is coating the Skittles dissolves into the water and spreads out due to a process called diffusion. The sugar will always move from the area where there is lots of sugar to a place where there is less. So you see the colored sugar move across the plate.
Wow!
Oobleck.
A mixture of cornstarch and water is a non-Newtonian fluid, meaning its viscosity resistance to flow changes depending on the applied force. When moved slowly, it can slide past each other, allowing the mixture to flow like a liquid. When a sudden force is applied, like tapping or squeezing, the particles tangle and lock together, causing the mixture to become more solid-like, showcasing how viscosity changes under stress.
Hello, today we are going to be doing the egg in a bottle experiment. The materials needed are egg, match, and a flask. First, light up a matchstick and put it inside the flask. Then put the egg on the mouth of the flask. When the air inside the bottle is heated, the molecules or tiny particles inside the bottle spread out, increasing air pressure. As the air in the bottle cools, the air pressure decreases. The greater outside air pressure pushes the egg into the bottle. Blowing into the bottle raises the air pressure again.
Water, ice, soap, stirring rod, and a food coloring.
Next step is we're going to add the salt of one of the cups and stir it until it dissolves. For the next step is add ice to both glasses. Next step is add a few drops of food coloring to the tap water and to the salt water to help distinguish it from the fresh water. As you can see, salt water is denser than plain water. It has more stuff packed into the same space. The colorful ice layer is mostly plain water, so the denser the salt water pushes up the plain water, the color floats.
Hi everyone! For today's experiment is we have the floating paper clip. So first is you will be needing a paper clip and a tissue paper. You will put the tissue paper with the paper clip slowly to the bowl with water. And then you will take the tissue paper out from the bowl to make sure if the paper clip is really floating by itself. Then, once you will put dishwashing soap, the paper clip will sink.
To make the magic balloon works, you need the materials like soda, vinegar, balloon, and a test tube. Then after that, you need to put the soda in the test tube. Then, after putting the baking soda in a test tube, you need to fill the balloon of vinegar. Make sure the vinegar is inside the balloon to make the balloon will inflate. Then, after putting the vinegar into a balloon, you need to place the balloon inside a test tube. You need to hold it clearly in the bottom of the balloon to make the balloon will inflate. See, as you can see, the balloon starting inflating. And that's all. Thank you.
I'll be making a matchstick rocket. First is to wrap the tip of the match to a foil. Then you light the tip of the match by a lighter and watch as it fires.
the rocket ship all by himself.
We need help! Say it with us, everyone! Swiper, no swiping!
Swiper, no swiping!
Oh man, you got me again.
Now that Swiper's gone, we can go to the party safely.
Yay! Welcome back, friends! We have successfully landed in Mars!
Let the scientific party begin!
Let's go!
Today, we will be demonstrating the balloon car experiment. All we need is an index card, straws, sticks, bottle caps, and a balloon. First, assemble the car using the previously mentioned materials. Next, attach the balloon to the straw and attach the straw at the back of the car. Lastly, inflate the balloon. The balloon car experiment demonstrates the Newton's third law of motion. When air from the inflated balloon releases, it pushes against the air behind the car, causing the car to move in the opposite direction.
Today, we're going to perform the bleaching experiment. And of course, we would need the following materials to do this experiment, which are the following: soda, bleach, a steering rod, and lastly, a beaker. The first thing to do is to pour the soda into the beaker. After pouring the soda, quickly follow it up with the bleach. Then you would observe that there would be a change in color of the soda. After you've noticed the changes, you would like to make the color much more brighter. So in what way? We will stir it until the color becomes much more brighter color of its variant. And do the process repeatedly, stir it until the liquid will slowly turn into a much brighter color. Or in other words, transparent. Of course, we would not make the work harder for us, so we will add more bleach. Then, back to stirring. And of course, we would like the results to be much more faster, then add more bleach. More bleach. You will then notice that the soda's colors have become much more brighter and transparent compared to before. And ta-da! Our experiment is all done. Here's the result. That's all for bleaching experiment. Thank you for watching.
Can air pressure move a coin? Let's find out. For materials, you need a plate, water, a small coin, a candle, and a clear glass. In the procedure, pour water onto the plate, light the candle in the center, drop the coin in the water, cover the candle with the glass. So why does it work? As the flame goes out, the air cools, creating a vacuum. The water rises, disturbing the coin and making it move. That's air pressure in action.
students, today I'll be showing you a simple clay experiment that you can make with simple materials. All you need is glue, cornstarch, food coloring, and detergent. First off, mix your cornstarch and glue and put tiny drops of food color. Here I use red food color. On a separate bowl, mix water and detergent and put your substance in. Then after that, things will get quite messy, and just follow my lead. And there you have it. Enjoy your clay!